In this video, we learn non-homogeneous linear equations. The linear differential equations which are not homogeneous are called non-homogeneous linear differential equations. That means here, if you observe this example, this is of second order, this is second order, this is second order, this is first order, this is first order, this is zeroth order. That means the order is not equal or not same. Then it is called non-homogeneous linear partial differential equation. That means the orders are different orders. The terms must contain different orders, not equal, unequal orders. Then it is called non-homogeneous differential equation. Then we learn how to find a complementary function. Let the non-homogeneous equation be written in this form: d minus m d dash minus z is equal to 0. Then this can be written as, in place of d, I am writing dou z by dou x. In place of d dash, we are writing dou z by dou y. Then, after simplification, the equation changes into the form p minus mq minus az is equal to 0. P minus mq is equal to az. So, if you compare this equation, with capital P into small p plus capital Q into small q is equal to capital R. If we compare with this, we get capital P is equal to 1, capital Q is equal to minus m, and capital R is equal to az. Therefore, the auxiliary equations is dx by P, dy by Q, dz by R, dx by 1, dy by minus m, dz by az. So first we consider these two fractions. Dx by 1 is equal to dy by minus m. Therefore, after separating variables, after separation of variables, it is easy to integrate. Therefore, minus m integral dx is equal to integral y. Therefore, y plus mx is equal to c1. Next, taking first and third fractions, that means first one and third one. After separating variables, we got this one. Integral dx is equal to integral 1 by z dz. Therefore, ax is equal to log m. This is of the form 1 by x dx. Therefore, log z plus log c. Therefore, z is equal to c to e power of ax. In place of c, constant, in place of c, we will substitute here. Therefore, z is equal to function of y plus mx into e power of ax. Similarly, the solution of this one, if it is of second degree, then one extra term will come here, e power of ax into, similar to homogeneous function, but the only difference is here we will get e power of ax term, extra, e power of ax, e power of ax. That is the only difference we have to remember. Taking an example, if we take an example, if we take an example, d plus d dash minus 2 into d plus 4d dash minus 3 into z is equal to 0. First we consider this one, d plus d dash minus 2 is equal to 0. So this may be written in the form d minus m d dash minus a into z is equal to 0. So if you compare with this form, m is equal to -1 and a is equal to 2 here, a is equal to 2. Therefore, complementary, therefore, e power of ax, it is of the form e power of ax into some function phi 1 of y plus mx. Therefore, a is equal to 2 here and m is equal to -1 here. Therefore, e power of 2x into phi 1 of y minus x. Next, coming to this one, d minus of 4d minus 4d dash minus 3 to z is equal to 0. Therefore, here m is equal to -4, m is equal to -4, a is equal to 3. Therefore, this is e power of ax into phi 2 of y plus mx. Therefore, e power of 3x into phi 2 of y minus 4x. Therefore, combining these two gives complementary function e power of 2x into phi 1 of y minus x plus e power of 3x into phi 2 of y minus 4x. Therefore, the complete solution is z is equal to e power of 2x into phi 1 of y minus x plus e power of 3x into phi 2 of y minus 4x. Next, coming to second example, this is of the form d. Second example is of the form d plus md dash plus a into whole square into z is equal to 0. So square means we have to take the two terms. That means this changes into standard form d minus md dash minus a whole square. Here m is equal to -3, a is equal to -4. Therefore, e power of ax into, here a is equal to -4, m is equal to -3. Therefore, e power of ax into phi 1 of y minus 3x plus x into e power of -4x into phi 2 of y minus 3x. Here because here square is there, that means two roots we will get. Therefore, x into, that's why we are writing x into. So this is the complete solution. Coming to a third example. R plus 2s plus 2 plus 2p plus 2q plus z is equal to 0. Here already we know that R is nothing but dou square by dou x square. So if you write in operator form, that becomes d 2d dash plus like this. So after simplification, we get m is equal to -1, a is equal to -1. Therefore, z is equal to e power of ax into phi 1 of y minus x plus x into e power of minus x into phi 2 of y minus x. This is another example. If you consider fourth example, here also in place of our dou square x by dou x square like this, if you write this in standard form, this becomes like this: d square minus d dash square plus d minus d dash. After factoring this one, this d square minus d dash square can be written as d plus d dash into d minus d dash. That means a square minus b square formula applying. After writing this formula, if we take common d minus d dash common, then this becomes d plus d dash plus 1 into z is equal to 0. Therefore, this is d minus d dash. So this one, for this one, m is equal to 1, a is equal to 0. That's why e power of 0x into, that's why we write e power of 0x into phi 1 of 1 minus x. Therefore, e power of 0x means 1. Therefore, phi 1 of y minus x. Next, if we consider this one, so for this one, m is equal to -1, a is equal to 1. Therefore, e power of ax means e power of x into phi 2 of y minus y plus mx means y minus x. This is y minus x. E power of x into phi 2 of y minus x. This is the complete solution. So we take another example. So on right hand side, we have sine of x plus 2y. The problem is d square plus 2d d dash plus d dash square minus 2d minus 2d dash into z is equal to sine of x plus 2y. So on right hand side, we have a function in x comma y. Therefore, we need to find pi also. That means particular integral. As we have discussed in last videos, the similar procedure we will follow here. The only thing, the only different thing is while writing complementary function, we in non-homogeneous we get e power of ax is extra. The remaining thing is similar. Okay. So if you consider this problem, here also first factorize this on left hand side. After factorizing, we get d plus d dash into d plus d dash minus 2. Therefore, first consider d plus d dash. So this can be written as d minus sof minus d dash. That means m is equal to minus 1, a is equal to 0. Therefore, a is equal to 0, m is equal to minus 1 means e power of 0 x into phi 1 of y minus x. Y plus mx means y minus x. Next, here for this one, d plus d dash minus 2. So after writing this in standard form, d minus half minus d dash minus 2. So m is equal to minus 1, a is equal to 2. Therefore, e power of x, e power of 2x into phi 2 of y minus x. Phi 2 of y minus x. Therefore, combining these two, we get complementary function. So this is complementary function. This is not z. This is complementary function. Phi 1 of y minus x plus e power of 2x into phi 2 of y minus x. Therefore, and for coming to pi, so here on right hand side we have sin ax plus by. If it is sin ax plus by, we will write in place of d square. Already we have previously discussed. In place of d square, we write minus a square. In place of d dash, in place of d dash, we write minus ab. In place of d dash square, minus b square. That means after squaring, we have to write minus. After multiplying a into b, we write minus. After squaring, we write minus here. Therefore, in place of d square, so if you compare this one, a is equal to 1 here, b is equal to 2. Therefore, a square is equal to minus 1, ab is equal to minus 2, b square is equal to minus 4. Substituting these values in this one, so d square is equal to minus 1, d dash is equal to minus 2, d dash square is equal to minus 4. After here, no need to substitute because there is no d square term here. There is no d square and also d dash square. That's why we are keeping as it is without disturbing them. Therefore, after substituting these values, the equation changes into the form 1 by minus 9 minus 2 into d plus d dash. In denominator, if you take minus common, so that is minus 1. So this has become 2 into d plus d dash plus 9. So in order to get in denominator, in order to get d dash and d dash square, where we have to conjugate this one. So opposite sign with opposite sign. After conjugating, we get this form. In place of d square, so here 1 by 117 into 2 into d plus d dash minus 9 to sine of x plus y. So after multiplying this sine of x plus y to these two terms, so 2 into d plus d dash into sine of x plus y minus 9 into sine of x plus 2y. Therefore, d of sine x plus 2y means, capital D means dou by dou x. That is dou by dou x of sine x plus 2y. x plus 2y. Dou by dou x sin x plus 2y means cos of x plus 2y plus into dou by dou x of x plus 2y. So here we are differentiating partial with respect to x. Therefore y is constant, 2 is constant, this becomes 0. Therefore dou by dou x of x is 1. So 1 plus 0. Therefore 1 into cos x plus 2y means cos of x plus 2y. That's why I am writing here cos of x plus 2y. Next coming to this, d dash means dou by dou y of sin of x plus 2y. So sin of x plus 2y means dou by dou y of means cos of x plus 2y, and again dou by dou y of x plus 2y. So which is equal to, here we are differentiating partially with respect to y. So x becomes constant, therefore 0 plus 2 into dou by dou y of y is 1, 2 into 1, which is equal to 2. Which is equal to 2. Therefore, that's why we are writing here 2 into cos of x plus 2y minus 9 into sin of x plus 2y. So after multiplying this one, 2 into this 2 cos x plus 2y plus cos x plus 2y becomes 3 cos x plus 2y. 2 plus 1, 3. So 3 cos x plus 2y. After multiplying this, if we take 3 common, 3 by 117 into 2 cos x plus 2y minus 3 into sin of x plus 2y. Therefore, after simplification, this 1 by 39 into 2 of cos x plus 2y minus 3 of 3 into sin of x plus 2y. So this is the PI. This is PI. This is PI. So for complete solution, we write complete solution as CF plus PI. Therefore, complete solution is Z is equal to like this 5 1 of y minus x plus e power of 2x into 5 2 of y minus 2x plus 1 by 39 into 2 cos x plus 2y minus 3 sin x plus 2y. So this is the procedure for finding particular integral in non-homogeneous linear partial differential equation. The same procedure will be followed in homogeneous, non-homogeneous, but the only different thing is while writing complementary function, we get e power of ax. One thing extra, that is e power of ax will get extra. That is the only difference. So this is the procedure to be followed for finding particular integral in non-homogeneous linear partial differential equation. So this is the procedure. So this is the, once again I am explaining the CF. So here e power of ax term, we get only e power of ax extra. That is the only thing. E power of ax, e power of ax. The remaining thing is same. So here you have to observe, this is not z, this is CF. CF into 5 1 of y minus x plus e power of 5 2 of y minus x. So based on this, we will solve, you may solve some more examples from textbook. You have to remember, whenever if you see P, the most important thing is you must remember dou z by dou x, and if you see Q, it is equal to dou z by dou y. Similarly, the important things to remember is dou by dou x means capital D, dou by dou y means capital D dash like this. These are the important things you have to remember. R means dou square by dou x square. T means dou square by dou y square like that. So in R means dou square z by R means dou square z by dou x square. T means dou square z by dou y square. P means dou z by dou x like this. And Q means dou z by dou y.